Now, if we looked at this, and this is, we're taking a quick look at this term, and we see something interesting. This is from the boundary condition with spring constants. So what we see is we see n, and often this is written more like gradient of c times u, which in this case is going to be two variables, plus q times u is equal to g. Now, the q is listed with several variables. It has q11, q12, q21, and q22 times the displacement in the x and the displacement in the y. And it's equal to G1 and G2. But we have this term, which what I'm going to put right here is call it traction 1 and traction 2. And that line right there was a mistake. And now I'll go back to it. These tractions are surface tractions. And effectively what we want is we want a spring to behave like that. What I'm getting at is, here's the bottom of the beam. Looks like this. We essentially want this to be a spring, so when the displacement comes down a certain amount, namely U2 is equal to some number, the force responding to it would be in this direction, and that force, or the traction, too, would be some constant, spring constant, times U2. So how can this be made to behave like that? Well, if we move this equation to the other side, what you'll see is something like this. You will see plus and a minus. So suddenly you'll see this on the right-hand side. So if you make this one and this one and this one 0, all you'll get is traction 1 here, and traction 2, the applied loads, will become G1 now, and the other one will become G2 minus some spring constant, which happens to be Q22 times U. So the question is, how does this deflection work? I mean, how is this completely, what is this value? Because this and this are going to be 0. So all I want is for this spring traction to show up there. But this is, if you remember, we had a beam, it had a thickness, and so we were just putting a pressure load on here. So here's your thickness, and I believe our thickness in our particular beam was assumed to be 0.01, if I'm not mistaken. That's right, 0.01. So what I want is a traction load that is going to be some force divided by 0.01 times this wart length, which if I look back, I'm looking back at the other computer, and I am going to look inside the MATLAB code that I produced, and I'm going to see that it was from 9.9 to 10.1, or this distance was simply 0.2. So 0.2, my spring constant was supposed to be 100 if I remember right. Yes, 100. So 100 divided by 0.01, 0.2, times the deflection in the y direction. Well, 100 divided by 0.1, let's check that out real quick. 100 divided by 0.01 divided by 0.2 ends up being 50,000. So this becomes 50,000 times U2. So is this the value that goes over there? And we got to think about that. So I'm going to pause this video, or actually the best thing for me to do is to stop this one and go back to that one.